Hi, we are from Group 2 and our element is potassium. I'm Komal and today I'll be talking about the basic information of potassium. Now, potassium is one of the essential alkaline metals found in Group 1 of periodic table. Our presentation will cover potassium basic information, including the position in periodic table, atomic structure, physical appearance, properties, and importance in chemistry in everyday life. Let's begin with the fundamental details of the element. Now, potassium has a chemical symbol K and is derived from a Latin word called helium. Its atomic number is 19, meaning there are 19 protons in the nucleus. The molar mass of potassium is 39.0983 grams per mole, which is shown in the top right corner of its periodic table block. In terms of the electronic configuration, potassium can be represented as 2.8.8.1 or in full notation as argon 4 as to the power of 1. This configuration clearly indicates that potassium belongs to period 4, group 1 and falls in the S block of the periodic table. Now onto the position in the periodic table. If you refer to our poster, you will see that potassium is highlighted in red on the periodic table diagram. Potassium is a group 1 element and is also known as alkaline metals, which is highly reactive when it comes with water. Being in period 4 means that it has 4 electronic cells. These characteristics help us to determine the behavior of potassium in chemical reactions and physical properties. Now, onto the appearance and physical state, potassium is a soft silvery grey metal as shown in the image in our poster. It can be easily cut with a knife because it's less dense than any other metals. At 20 degrees Celsius, potassium is at solid state. However, it will react very quickly with oxygen and moisture in the air. That is why it is stored in oil to prevent oxidation. Onto the crystal structure, potassium adopts a body-centered cubic, also known as BCC structure. This structure affects its density, melting point, and electrical conductivity. These chemical characteristics reflects why potassium plays an important role in industrial processes, laboratory reactions, and biological systems. Finally, onto the discovery in historical background, potassium was discovered in 1807 by Sir Humphrey Davy, a famous English chemist. It was actually the first metal ever isolated using electrolysis, which makes this discovery a very important breakthrough in the history of chemistry. In conclusion, potassium is a fascinating and essential element found in Group 1 of the periodic table. With a symbol K, atomic number of 19, molar mass of 39.0983 grams per mole, it is known for its soft metallic appearance, high reactivity, and its importance in chemical properties. From the electronic configuration to the discovery of Sir Humphrey Davy, potassium remains a crucial element in both scientific studies and practical application. This sums up the whole basic information of potassium. Now, I'm going to pass it on to the next person. Thank you.
Hi, my name is Inta Susana, and for this part, I'll be explaining about the physical characteristic of potassium. So, potassium is a shiny silvery white metal that actually looks really soft. So, unlike most metals, potassium is very soft, so you can cut it with a knife. At room temperature, potassium exists as a solid and it belongs to the alkali metal group. And what interesting about potassium is because of its density, which is 0.862 grams per cubic centimeter, which make it the second least dense metal after lithium. So because of this, potassium is light enough to actually float on water. And next, potassium has relatively low melting and boiling points compared to most metals, and it melts around 63 degrees Celsius, which means if you hold it near a warm surface, it can become very soft quickly, and it boils around 760 degrees Celsius. In terms of magnetism, potassium is diamagnetic, meaning it's not attracted to magnets. For taste, pure potassium has a strong bitter salty taste, but of course we don't taste the element itself because it is reactive. And lastly, potassium is a good conductor of heat and electricity just like other metals, so this make it useful in various industrial applications. So overall, potassium is a soft, shiny metal with low density, low melting point, and good conductivity, making it unique compared to many other metals.
Hi, my name is Payal and I will be talking about the chemical characteristics of potassium. So let's look at the core characteristics of potassium. First off, we have is high reactivity. So as we all know, potassium has very high reactivity and it's quite high up on the reactivity scale. Potassium is a strong reducing agent, meaning it will aggressively seek to lose out its 4 valence electrons. This is why its natural and stable oxidation state is always positive 1. Secondly is the bonding behavior. It primarily forms ionic bonds when reacting with nonmetals like halogens, driven by its desire to achieve a stable electron configuration, which is 8 electrons in the outermost shell. Third and most crucially is the storage requirement. As we all know, and as mentioned earlier, potassium is highly reactive. Because it oxidizes rapidly in air and reacts violently with moisture, potassium must be kept under kerosene or an inert gas. So this protective layer is a non-negotiable safety measure. Finally is the flame test. This is a very simple identification method. A flame test is used to identify metal ions based on the characteristic colors they produce when heated in a flame. How the flame test work is that when the metal ions are heated, the electrons will become excited and release light or specific wavelengths. So this produces different flame colors for different elements. So when potassium is heated, they will release a vivid lilac or violet color to the flame. Next, moving on is the reactivity. So the intensity of the potassium's reactivity is best illustrated by its key equations. So these reactions demonstrate its role as a powerful electron donor. The most notorious and vigorous reaction of potassium is with water. This process is incredibly violent and highly exothermic, meaning it releases a massive amount of heat instantly. This heat is so great that it releases hydrogen gas, and that hydrogen gas released will spontaneously ignite, leading to an explosion. That is why it's highly reactive. So, the equation with water, it will usually get you will usually get potassium hydroxide, which is KOH, and this is a strong alkaline, giving the group its name, the alkaline metals. So next, moving on with the reaction is with oxygen. So with oxygen, the reaction is very complex. It often forms potassium superoxide, but in simple terms, it readily forms an oxide. With halogens, on the other hand, potassium forms ionic halide salts. So, for example, if potassium is combined with chlorine, it will form potassium chloride. Now, moving on to acid. When potassium reacts with acids like hydrochloric acid in a displacement reaction, they always form the corresponding salt and, of course, hydrogen gas, which is highly flammable. So, to summarize, in terms of ranking of the reactions from the most reactive to the least reactive, this usually is depend on the spontaneity and intensity of the reaction under typical laboratory conditions such as room temperature and atmospheric pressure. So we'll start the ranking from most reactive to least reactive, starting off with water. So obviously speaking, water is the most reactive on the list. Potassium will react violently and explosively with water at room temperature, and it's highly exothermic, producing hydrogen gas as mentioned. Next is with halogens. So ionic halide salts will be formed. So yes, it also reacts very vigorously and also explosively with halogens. So while the reaction with chlorine gas may sometimes require a slight nudge of energy, for example, heating to initiate it, once started, the reaction is extremely vigorous and highly exothermic, producing the corresponding ionic halide salts. The third is with acids. So when potassium is mixed with acid, they will form salt and hydrogen gas. So the reaction with acids, for example, HCl or H2SO4 is very vigorous and exothermic. However, because most common acids are often aqueous solution, meaning they contain water, the observed reaction is largely violent and the same reaction as with water. So this is often more complicated by the presence of the acids. So it's very similar and it's essentially a slightly modified version of the metal water reaction. Lastly is with oxygen. So potassium reacts rapidly and spontaneously with oxygen in the air. This process is called tarnishing, even at room temperature. However, this reaction is typically less intensely explosive than reactions with water or halogen. It starts quickly, forming a dull layer of oxide or superoxide on the surface, which is why pure potassium must be stored under kerosene or an inert gas. If the metal is heated or if it forms a thin layer, scraping, it can ignite and burn violently. but the impromptu reaction with atmospheric O2 is generally ranked slightly less rigorous than the reaction with water. So, in summary, from the most reactive to the least reactive, we have water, followed by halogen, acids, and oxygen. You may scan the QR code to watch a video on the reaction of potassium with water. Now pass it on to the next person.
Hi everyone, today I'm going to talk about 5 essential functions of potassium in our body. Potassium is a key mineral, an electrolyte that keeps many of our body systems running smoothly. The first point is potassium helps our muscle contract. Every time you move, whether it's walking, lifting something, or even your heart beating, potassium works with sodium to send signals that make your muscles tighten and relax. Without enough potassium, muscles can feel weak, cramp easily, or even twitch. So for the second point is potassium is crucial for nerve functions. Our nerves communicate using electrical impulses. Potassium helps generate these impulses, allowing messages to travel from the brain and then to the rest of our body. This is how we sense touch, react to dangers, and also control our movements. So for the next point is potassium also regulates our blood pressure. It helps balance sodium level in the body. When potassium is at a healthy level, it reduces the strain on blood vessels wall, helping maintain normal blood pressure and supporting heart health. The fourth one is potassium also helps support metabolism. It activates enzymes that convert the carbohydrates we eat into usable energy. This means potassium helps power everything from basic body functions to physical activity. Finally, potassium helps maintain fluid balance. It controls how much water moves in and out of cells. This balance is important to prevent dehydration, swelling, and to keep organs function properly. In summary, potassium is vital for muscle movement, nerve signals, blood pressure control, energy production, and fluid balance. So remember to include potassium-rich foods like bananas, orange, leafy greens, and potatoes in your diet.
Okay, so now I'll present about the applications of potassium. Potassium is not only an essential element for the human body, but it also widely used in many industries because of its reactivity and also unique chemical properties. Potassium plays important roles in our daily life. So here are the 5 main applications of potassium. First, potassium is very important in the medical and health field. In our body, it helps to regulate our nerve signals and also muscle contraction, and especially the heartbeat. So that's why potassium is included in electrolyte drinks, supplements, and also hospital IV fluids. So this can help to prevent muscle cramps and also irregular heartbeat. So next, in the food industry, potassium compound act as preservatives to prevent the mold and bacterial growth in food. It is also used in low sodium salt, especially for people who need to reduce sodium intake. And then the next one, the third application is in energy storage. Potassium is used in developing potassium ion batteries. These batteries are cheaper than lithium because potassium is more abundant. It has a good energy storage capacity and may be used in future renewable energy system. And the fourth application is potassium compounds are used to produce soaps and also detergents. Potassium hydroxide, also known as caustic potash, is a key ingredient in making soft soaps and liquid detergent because potassium-based soap dissolve more easily in water and create a softer, smooth texture. And it is very suitable for products like liquid, hand wash, and also shampoos. Okay, so the final application is in agriculture. Potassium is one of the 3 main nutrients found in fertilizer together with nitrogen and also phosphorus. It helps the plant to grow stronger and also improve their water retention. So this makes the potassium essential for healthy plant growth and also successful farming. So to conclude everything, potassium unique properties such as high reactivity, good conductivity, and also essential biological functions make it important in both life and also industry. It supports the body processes like fluid balance, nerve function, while also being widely used in medicine, food preservation, batteries, detergent, and energy. Overall, potassium is a versatile element that plays a crucial role in daily life.